Hello everyone, welcome to this session. In this video we are going to discuss about shortest job first, a preemptive scheduling algorithm. The previous video we discussed about the shortest job first without arrival time, uh, uh, non-preemptive shortest job first without arrival time, how the process are executing one by one. In the shortest job first with preemption, it does always preempt the currently executing process. So when the next CPU burst is less than currently executing process. So this is the case of the preemption. Non-preemption, so it doesn't allow the currently running process to preempt completely. It finishes its CPU burst, then it is leaving the next process. This is the difference between the preemption and non-preemption. Preemptive shortest job first, it is also called as the shortest remaining time first scheduling algorithm. So in this example, the process P1, P2, P3, P4, four processes there. All the processes are arriving at the different timings. The arrival time here mentioned 0, 1, 2, 3. So I will just explain this concept with simple real-time example. Then you can match us with this example. Then we can proceed for calculating the Gantt chart. Usually the students will misunderstand, and as it is they will solve like as a 4 is the first and 5 is the second one and 8 is the next process and 9 is the thing. First we need to note down as what is the arrival time is given here. So arrival time is given, based on that only it will execute. At the time of 0, no other process enter into that code, only one process is available. So now we will just look on some real-time example. Suppose you just assume you're going to bank and get for some service. Bank opening time is 10 o'clock. Okay, so the first person 1 enter at the bank at the 10 o'clock itself. So no one at the time enter into the bank, so only one person is there. So the manager is doing the service for the first person, but he need totally to complete its process inside the bank, he needs 3 hours. You just assume it. The person 1 needs 3 hours to complete its process. But at the time of 10, no one is there. So manager will start giving the service for the person 1. Immediately after 15 minutes, now time is 10:15. The person 2 is coming, but he needs to complete its work only 10 minutes. So usually what we will do it, so his time to complete its process only 10 minutes. So we will just hold on the person 1. Sir, can please wait. I will just complete I am just going to giving the service for the person 2. Then I will just come back. Right. So this is the way the shortest job first preemptive algorithm is going to be work. So now the time 15, at the time of 10:15, the person 2 is going to be getting service. So he needs only 10 minutes. So 10 minutes means at the time of 10:25 he will complete its process. At the time 10, the person 1 arrived, till time 15 his work is done. So totally he need 3 hours to complete his work, but 15 minutes he completed. So balance amount 2 hours 45 minutes is there. Okay, now time is 10:25. So now again you just consider one more person is coming, P3. Okay, so the person 3 is coming. He needs to complete its work 3 hours. So now in the bank only 2 person is there. So P2 came and he finished his work and he left the bank. His work was over. So now the person 1 and person 2. So person 3, he needs to complete its job 3 hours. Person 1 needs to complete its job 2 hours 45 minutes. So now we need to compare this two. So who is lesser time taking to get service? So 2 hours 45 minutes. So we will just start with the P1. That is person 1. That is called as shortest remaining time first. So person 1 already gets serviced. In between someone is getting the service after it's left out. Now again one more person came. Now we need to compare with the remaining time of the executed process and then newly arrived process. Suppose in this case the person 1 came but he needs time only 1 hour means now the chance is given to the person 3. Clear? Because the P1 is having 2 hours 45 minutes but the person 3 need only 1 hour. So which one is lesser? Person 3. So like that we need to process. So we have to check the arrival time. Based on that, what is the available burst time is there, we need to compare with the CPU burst time. Then we need to give a chances to the other process. So I hope you will get a clear idea now how the preemptive shortest job first is working. So now we can make the Gantt chart for according to this example. So now the P1 came first because the arrival time 0, no other process is there, only P1 is there, it start executing. So while executing the process 1, now time is 1. See, at the time of 1, process 2 was arrived. So now we need to compare the burst time of P1 and then P2. So which one is lesser? P2 is having less burst time compared with the P1. So 1 minute completed. So 8 minus 1. So remaining 7 is there. So 7 and then 4. So which one is smaller? So 4 is smaller. So we are just hold on the P1. Now the chance is given to the P2. P2 executing 1 minute. At the time of 2, P3 was arrived. So now 1 minute complete. So the balance execution time is 3 for the P2. So now P3 is arriving at the time of 2. Now we are just checking the burst time of P3 and then P2 and P1. Which one is lesser? So now the burst time is less for the P2. So we are not preempt this process. The P2 is going to continue its process. Okay. Next 1 minute P4 was arrived. Now time is 3. At the time of 3, again the P2 is executed 1 minute. So now the balance amount is 2. So now at the time of 3, P4 was arrived. Now we need to compare all the process burst time. Upcoming the burst time is 5 and then here the remaining time is 2. So the P2 is going to be continue its process. Okay. So now P2 was complete its process at the time of 5. P2 completion. So now again we need to check the remaining process. Now the time is 5. All the processes are arrived in that line. So now simply you just compare the remaining burst time to execute. So P1 need to execute 7 and P3 need 9 and P4 is 5. So now P4 is getting a chance to execute. burst time is time 5. So the completion time is for the P4 is 10. So now P4 completed, P2 already completed. Again the two process. So we know very well P1 is less. So the completion time is 7. So total 70. So the next P3 is going to be start and it needs 9 burst time. So it will execute on time 26. So now we need to calculate the waiting time and turnaround time as it is. So now the one thing we need to note down, the waiting time calculation now. So we have a arrival time. P1 arrived at 0, P2 arrived at 1, P3 arrived at 2 and P4 arrived at 3. So this is our Gantt chart, the previous slide what we made. P1 26. So now we need to calculate the waiting time for the each and every process. So we need to do some careful calculation. How much time is waiting time for the P1? So when the P1 is complete its process, first we have to check that. So P1 complete its process at the time of 17. So it is getting the chances at 10. Okay, but simply we can't able to tell the P1 waiting time is 10. Since we need to check two things. What is the arrival time of P1? Also, the P1 is already executed in this timeline or not. We have to check it. So P1 arrival time is 0. So no issues. But the P1 got chances at the 1 minute to execute this place. So we have to eliminate these things. So what is the actual waiting time of P1? So now here 1 to here. This is the waiting time. So what we discussed in the example of the bank exam. So the person is came at 10 o'clock. He gets chance to execute his work. Till 10:15 he was getting the services. But after the second person came, so he is in a hold on state. Again he is getting the chances after 10 minutes. So his waiting time is only that 10 minutes. Okay, so that is the meaning here. So P1 is getting the chance at initially and after 1 minute it's leaving its process. Again at the time of 10 P1 getting chances. So now this is the space its P1 is waiting time. So 10 minus 1, the P1 waiting time is 9. Clear? So now P2 waiting time. So when the P2 is getting the chance to execute at the time of 1. Okay, now we need to check the arrival time. When the P1 is arrived, P2 arrived at the time of 1. So getting the chances at the time of 1 and his arrival time is also 1. So it is immediately get chances to execute. So 1 minus 1 it is 0. So P2 waiting time is 0. Let's come to P3. P3 it gets chance at the time of 17. Okay, so 17 is not the waiting time for the P3. So we need to check when the P3 was arrived. So P3 arrived at the time of 2. So 17 minus 2. So 15 is the waiting time for the P3. Similarly for P4. P4 is getting a chance at the time of 5. But it arrived at 3. So 5 minus 3. So P4 waiting time is 2. So now as usual we have to calculate the average waiting time. So you will get around 6 millisecond. So like that, similarly we need to calculate for the turnaround time. So turnaround time is basically compare with completion time. Okay. So like that, we can find the waiting time for the preemption. So what is the difference between the preemption and non-preemption? With the same example, so with the same burst time of all these processes, if we are just executing, so which process is getting a minimum burst time? It is going to be get longer waiting time. So obviously, the same example if you solve and then check it with the non-preemption shortest job first means you will get around 7.75 average waiting time. So comparatively, the preemption shortest job first is a less waiting time. So this is the one advantages of the preemptive shortest job first. So in the meanwhile, all the scheduling algorithms are having some advantages as well as the disadvantages. So based on the scenarios and which scheduling algorithm is preferable, so that we can apply. So I hope you can able to get the clear idea on preemptive and non-preemptive. So we will meet in your next session. Thank you.